Good morning, students. This is Rudrodeep sir, and today we have gathered to discuss some topics on the very first chapter of class 11 organic chemistry, which is some basic principles of organic chemistry. I hope all of you can see the whiteboard from there. Okay, before starting the chapter, I need you to know something which is very important. What kind of bonds are involved in organic chemistry? The kinds of bonds that are involved in organic chemistry are: one, covalent bond, and sometimes coordinate covalent bonds. So you may have known what are these two types of bonds. Covalent bonds we have learned in chemical bonding, and coordinate covalent bonds as well. Okay, so the only difference between these two types of bonds is in covalent bonds, both the electrons during bond formation, two electrons are coming from both the atoms present in a compound. But in case of coordinate covalent bonds, two electrons are coming, but only one of the two atoms will give up the two electrons for bond formation. This is the difference, nothing else. So how many types of covalent bonds, or how many types of bonds, how many kinds of bonds are involved in organic chemistry? Three. Number one, single bond, where only two electrons are shared. Double bond, where 4 electrons are shared, and triple bond, where 6 electrons are shared, 3 from each atom. So these three types of bonds are involved in covalent in organic chemistry. Okay. Now today we shall start the chapter from the first topic, that is structural representation of organic chemistry. Structural representation of organic chemistry, organic compounds. Structural representation of organic compounds. Okay, so how can we represent a compound which is organic in nature? See, most of the organic compounds are made up of carbon and hydrogen, and you know carbon can form 4 bonds at a time. Why? Because it is tetravalent in nature. If all the it can also happen that all the carbon, all the hydrogens are bonded with a single carbon. It can also happen that 3 hydrogens are present and 1 OH is there. So in that way we will represent the organic compounds. Let us represent ethane in different way. Ethane and ethyl. The structure of ethane is this: one single bond between 2 carbon atoms. This is the structure of ethane. How do we know that it is ethane? In class 10 you must have seen that 2 carbons mean eth, and as all the bonds are single bond, ane is added. Then what is ethene? Ethene is this one. This is ethene. Why ethene? Eth means 2 carbons and double bond means ene. And this one is ethyne. Why? Because eth means 2 carbons, and as there is a triple bond we call it ethyl. So this is how we represent ethane, ethene and ethyne. In a short way we can also represent ethane as CH3, single bond CH3. It can be represented as CH2, double bond CH2. Why? Because each carbon is carrying 2 hydrogen atoms. And CH, triple bond CH. Or you can say also, or see, in 3 ways we can represent these. Or we can represent ethene as this as well: C2H6. How many carbons are here? 2. How many hydrogens are here? 3 plus 3, 6. Similarly, C2H4. and similarly C2H2. So these are the ways by which we can express ethane. These are the ways by which we can express ethane. So this only ethane, about ethane I have discussed. We have discussed, okay, I have told, but for in case of all the compounds, the same rule applies. Okay. So the thing is you will have to represent any organic compound in that way. For you can show the hydrogen individually, or you can write the hydrogens together in a single point. Okay, we can do that. Okay, now the thing is, suppose you have been asked what is this compound, so what will you say? You will say, sir, I don't recognize this compound because I have never seen that. Actually you may have never seen that, but it is very much easy. You will have to place carbon in each corners and at the end. You will have to place carbon atoms in each corners and at the ends. Okay, for example, this is an end, so here you will add a carbon, here a carbon as well, carbon, 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 carbon. Okay, and this one is also carbon. So if you write in that way, carbon, 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 carbon. Now what we will do? Now the thing is that the thing that we are going to do is the satisfy the valency, tetravalency of carbon by hydrogen atom. See, this carbon has made only one bond. It means three hydrogens can be placed here. Why? Because carbon can make four bonds at a time. This carbon can make two hydrogen bonds, two bonds, two bonds, two bonds, two bonds, two bonds. Now let us come to this carbon. This carbon has already made four bonds, so no need to add any hydrogen in it. C double bond, 3, 4. 2, 1, 2, 3, 4. See? So this is how I have converted this complex compound into a simple one. Okay, so in that way we will represent, in that way we can also represent a compound. Let me give you some more examples. If you are asked what is this compound, this one, so you will say in the language of mathematics, you will say, sir, this is a triangle, it is not a compound. But I will say, no, this is cyclopropane. I will say this is cyclopropane. Why? Because I told you all the corners will be occupied by carbon. See, now we will have to satisfy the tetravalency of carbon. See, now place number 1, number 2, number 3. Okay, we will get to that, how nomenclature is done. Still, just see that 1, 2, 3, 3 means then propane, as it is a cyclic compound. We will add a cyclo before propane. The cyclopropane is this compound. This compound is cyclopropane. In that way, cyclobutane. In that way, cyclohexane. In that way, benzene. Okay, so all the compounds can be represented by this method. Okay, now let me tell you what happens when a functional group is involved. What is a functional group? First, you need to know that a functional group is an atom or a group of atoms responsible for the chemical behavior of an organic compound. A functional group is an atom or a group of atoms responsible for the chemical behavior of an organic compound. For example, OH group is a functional group, which is known as hydroxide group. And because of this presence of this OH group in organic compounds, all the compounds which contain this functional group as their main functional group are alcoholic in nature. Okay, these are halides. So in that way, these are carboxylic acid. So all the organic compounds containing COOH group show what? Acidic behavior. So this is the thing that we need to know, that because of the presence of functional groups, an organic compound behaves differently. Okay, so this is what happens. Suppose in that way, just before this, suppose this is an example, CH3. Suppose, no, not this one. Suppose you are asked, what is this? You will say, sir, as you have told me, as you have told us, we will have to place carbon here, 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 and here. Okay, total 5 carbons are there. And the first carbon is satisfied by 3 hydrogen, second one is 2 hydrogen, third one is only 1 hydrogen. Why? Because 3 bonds are already made. Ca. Fourth one CH2, fifth one CH3. So this is the compound that we desire. Okay. Now the thing is, OH group is connected to this CH group. So in case of representing a functional group by this method, we are not going to just write only a bond. We will have to mention which functional group present is there, which functional group is present there. Okay. In case of carbon and hydrogen, only lines are enough. But in case of representing a functional group, you will have to mention the structure or the functional group clearly. Is that clear to everyone? Oh, right. So this is how we represent the organic compound. We can also represent the benzene in that way. Okay, no need to write all the structure. We do not need to write in that way. So this is quite a big structure, but if you represent benzene and this one as this one, it will be quite easier for us. Okay, so that is why this one is preferable, not this one. So both these are correct, but this one is preferable over the second. So this is how we represent the organic compound. Okay, so all the bonds are represented by single lines. Okay, it can be single line or it can be double line. A single line means single bond, and single bond contains only one sigma bond. Okay, when a double bond is involved, then one of them is a sigma and the other one is pi. If a triple bond is involved, then one of them will be sigma and the rest two will be pi. So in between two atoms only one sigma bond is possible. Suppose there is carbon-carbon single bond, then it is a sigma bond. Suppose there is carbon-carbon double bond, then it is one of the bond is sigma and the other one is pi. And if there you can see one carbon-carbon triple bond, then one of them will be sigma bond, and the rest two bonds will be pi. So only one sigma bond can be made in between two atoms. Is that clear to everyone? I hope yes. Okay, so this is how we represent the organic compound. This is what a single bond, double bond, triple bond. Okay, so we will skip to the next topic.